Let's find the domain and range of the function f of x equals 3x over x minus 4. Now the domain, we just need to avoid when the denominator equals 0. Don't just say avoid denominator, or don't just say avoid x minus 4. That doesn't make sense. We've got to avoid when the denominator equals 0. Emphasis on equals 0 here. So we need to avoid when x minus 4 equals 0. Add 4 to both sides. We need to avoid when x equals 4. So to avoid when x equals 4, all reals except x equals 4, domain is negative infinity to 4, union 4 to infinity, parentheses in all these spots. Now what about the range? Well, the range itself of a function is hard to compute directly, but recall that we just a moment ago said that the range of f is the same as the domain of f inverse. So instead of finding the range of f directly, let's find the domain of f inverse, which means that we need to first find f inverse before we find its domain. Let's just convert that f of x into a y. Swap all the x's and y's. So you have, instead of y equals 3x over x minus 4, we have x equals 3y over y minus 4. And now we just need to solve for y. To do that, let's multiply by denominator on both sides. Okay, standard thing of when you have an equation with fractions, let's not have fractions. So multiply both sides by x minus 4, and you have x times quantity, y minus 4, is equal to 3y. Now, there's y's on both sides. We need to solve for y. How about let's distribute x on the left side. So xy minus 4x is equal to 3y. There's still y's on both sides, but now there's terms on the left side. So let's get all terms with y on one side and all terms without y on the other side. So subtract 3y on both sides, add 4x to both sides. And now both terms that have y are on the left side. xy minus 3y is equal to 4x. What are we going to do here? We've got two terms with y and we need to solve for y. This goes back to an idea that we saw very much at the beginning of the semester. Let's factor. Factor out y. And you have y times the quantity x minus 3 is equal to 4x. And then to solve for y. See, the great thing about factoring was we went from 2 written copies of y to only 1 written copy of y. And now to solve for y, we just need to divide both sides by x minus 3. So y is equal to 4x over x minus 3, or in other words, f inverse of x is equal to 4x over x minus 3. Now that we have the inverse function, again, our question was the range of f. So we're going to now deal with the domain of f inverse. And here's f inverse. And so the domain of f inverse, we need to avoid x equals 3, yeah? So the domain of f inverse is negative infinity to 3, parenthesis, union, parenthesis 3 to infinity. So the range of f is also that same thing. So we've got the domain of f up here. We have the range of f down there. Let's try another example. We'll find the domain and range of the function f of x equals 2x plus 3 over 4x plus 5. The domain, okay, well, avoid the denominator equals 0, so avoid 4x plus 5 equals 0. So when you solve for x there, the only value of x to avoid is negative 5 fourths. Okay, so there's the domain, negative infinity to negative 5 fourths, parenthesis union, parenthesis negative 5 fourths to infinity. What about the range? Again, we're going to get the inverse function because instead of computing the range of f directly, let's compute the domain of f inverse. So we need to get the inverse function. First, replace the f of x with a y, swap the x's and the y's, multiply both sides by denominator. Standard thing you do when you have an equation with fractions. Multiply both sides by the LCD. In this case, that LCD was just the one denominator there was. So multiply both sides by 4x by 4y plus 5. Distribute the x on the left side. We're trying to solve for y, recall, so let's get all terms with y on one side and all terms without y on the other side. So 4xy minus 2y equals 3 minus 5x. Okay, now that we have all terms with y on one side, what do? We need to factor out y. Okay, so 4x minus 2, quantity, times y outside parentheses equals 3 minus 5x. One last step to solve for y, divide both sides by what's in parentheses. So you have y is equal to 3 minus 5x over 4x minus 2. And then we can just rename that y here again as an f inverse of x. So we've found the inverse function, but the reason we found the inverse function was because we need to compute the domain of the inverse function because that's going to be the range of the original function. So for the domain of f inverse, we need to avoid 4x minus 2 equals 0. We're going to end up avoiding x equals 1/2. That's the only number that causes a problem. So the domain of f inverse is the same as the range of f. Now, let's look at the following. You have access to this mini paper version of transparency. So it'd be nice if you could work on this at home. So what you do on this paper, and if you don't have the handout printed nicely, you can still mimic truly the whole process really on just regular paper. Um, but draw a function on the front side and then diagonally flip to see if the inverse is a function, right? So I'd like to really just try this. Okay, let's demonstrate on a couple cutout copies of this here. So, for instance, we had seen the example of, like the line y is equal to 3x plus 2 earlier. So like something that looks like this. And then when you diagonally flip, this still ends up passing the vertical line test because over here, pre-flip the horizontal line test passed. We saw this example. Yeah, we saw, for instance, y equals 2 to the x. Looked like that. Okay, and this, well, it's a function, passes the vertical line test. This is a one-to-one function because it passes the horizontal line test. And the great thing about a one-to-one function is that when you diagonally flip, the flipped picture passes the vertical line test. So I actually have this kind of done much more nicely here and laminated, knowing that I want to use this several times. So here's f of x equals 2 to the x. And then if we flip this diagonally like that, this is the inverse function, which also passes the vertical line test because the pre-flip version passes the horizontal line test. Here's another one. Here's the standard square root function. There's this point on here that I've labeled 49, 7. Yeah, and the horizontal line test passes, meaning in the flipped version, the vertical line test passes. And there's actually a point here, 7, 49. Here's another one. Another one that we've seen is the standard parabola, f of x equals x squared. Now this is an example where the horizontal line test fails, so this is not a one-to-one function. And the thing about diagonally flipping when the horizontal line test fails is now, in the flipped picture, the vertical line test fails. We see it here. This is not a function. This is not the graph of a function. One more, how about let's look at the absolute value. So this is another standard graph that you should know. It looks a lot like the parabola except that it's pointy. Yeah, and so a lot of the same features occur. The horizontal line test fails, and so if we do the diagonal flip in both of these, yeah, the vertical line test fails over here. So the diagonal flip version of the absolute value is not a function.